Hello everyone, welcome to the next video of our lab 1. So in the previous lab, we did the 4 tasks. First task is to generate a 8 megahertz clock from 100 megahertz clock using the inbuilt IP. Then we generated a 1 hertz clock using the 8 megahertz clock using the Verilog code. Then we created the mods 59 mod 60 counter using the 1 hertz clock, and then we converted the binary output of the counter into the BCD for the display on the 7 segment display on the board. Now we are going to display we need to integrate this with your 7 segment display. So for that, we need to understand how the 7 segment display works, and how to do the interface. So, so you can see that this is the Basys 3 board, and here you can see that there are 4 digits of 7 segment. As I told you, at a time you are displaying the data only on one display, but you are switching between the display at a very fast rate so that human eye cannot distinguish. So that's why in our code we have the 2 interfaces. One is the anode interface, which is the 4-bit signal, which is used to decide which digit is active at a time, and then the 8-bit cathode, which indicate how to which segment of this 7 segment. There is a 7 segment plus there is a decimal point here, so that's why there are 8 bits to display whether the corresponding segment is on or off. So it's active low, so 1 means off, 0 means on. Okay, so regarding the details about the Basys 3, you can see this PDF. You will get all the details which are there. We'll come back to this one once when we want to know more details about the interface. So right now we will talk about the 7 segments. So you can see that these are the pins which are connected to the 7 segment. So you can see that these are 1, 2, 3, 4, 5, 6, 7, 8 pins are there, which are used to decide what data to be displayed on the corresponding digit which is active. And then there are 4 pins are there, which is used to enable one of the display at a time. But it is the shifting between the digit is done at a much faster rate, so human eye cannot distinguish. Okay, so you can do the display as it is. So you can see that this is the A, B, C, D, E, F, G, and based upon that you can display any number. For example, if you want to display 1, you will make the B and C as high. If you want to display say 8, you will make every one segment on except the segment or except all the segments on. And if you want to display 0, then you will make all the segment except G segment as on. So you can see that this is 1, 2, 3, 4, and based upon that you need to do the appropriate display. Okay, so now we need to add a logic, because you can see that what we need to do is that on the 7 segment there are 4 displays. So on the left 2 we will display 0, and on the right 2 we will display the minute value. So this is on the 1 second value, and this is the 10th digit of the second. We will display it here, but we need to add a logic so that we can switch between this segment at a very fast rate. And when the corresponding segment is active, we need to pass the data. For example, when this segment is active, we will display 0. This segment is active, we will display 0. When this segment is active, we will display the tens value of a second. And when this segment is active, we will display the ones value of a second. So right now we'll write a very simple code, and later when we add the PMOD 7 segment display, we'll see how we can design using the FSM. So let's go back to the our code. Okay. So here, okay. So you can see that now I need to generate these outputs. So I will have the board display module. Okay. And the first is that it should have the clock, which is clock 100 megahertz, because from that we will be generating the lower clock. Okay. Then you will have the 4 inputs for digit 1, digit 2, digit 3, digit 4. We will have the digit 1. For that, we will have the digit 1 is on the right hand side. We will display the 1 second on that. Then we will have the digit 2 will display the 10 second on that. Then we'll have the digit 3, we will display 0 on that. And then we'll have the digit 4 will display 0 on that. Okay. And the output of this is the output is the this one, which is the SSD cathode, and SSD anode. Okay. So this is our task 5. Display seconds on 2 digits of board SSD. Okay, and rest 2 digits will display 0 value. Okay, so let's write a code for that. Now, to switch between the one, we need to generate a 1 kilohertz clock. So one option is that from the 8 megahertz clock, we can generate the corresponding lower clock. That is also possible. So there are multiple options are there. You can use any one of the options. So we will use one way of designing this display module, but you can come up with your own module also. Okay, but as long as logic remains the same, it should work. So I have the clock as an input. Then I have the digit 1 as an input. This digit 1 is 4-bit. Okay, so 3 down to 0. Then we have the digit 2, which is again an input, that is 3 down to 0. Then we have the digit 3, which is again an input, 3 down to 0. Then we have the digit 4, which is again an input, that is 3 down to 0. Then I have the output, which is the BSSD cathode, which is the output, and it's a 8-bit, so 7 down to 0. And load, which is the output, which is 4 down to 0, 1 bit for every digit. Okay, so the corresponding modules will be created now. So this is okay. So you have the input clock, then digit 1, digit 2, digit 3, digit 4, and the cathode and the anode output. Okay. One thing I think I forgot is that since these are the output of the always block, they should be defined as a register. Anyway, you will get the error when you try to synthesize it, but just I realized just now, so you need to make sure that when there is a variable is the output of the always block, it should be of the type register. Okay, so now what we need to do is that this clock is the 100 megahertz clock, and what we need to do is that from this clock we need to create a lower clock, and then we need to switch between the two digits, switch between the multiple digits of that clock. Okay, so what we are going to do is that we are going to design a counter, which is the 18-bit counter. Again, this counter is used to get the 1 kilohertz output, which is fast enough to switch between the display. Okay, so you have the range. Okay, so always count range is equal to count next. So this is our sequential circuit. Always at star count next is equal to count range plus 1. And what we are going to use is that at the last two digits, so they whenever they changes between the 0, 0, 0, 1, 1, 0, 1, 1, we are going to switch between the display. Again, this is a one way of doing it. You can always write the FSM, which we are going to do in the later videos, that we are going to write the FSM, which goes through the state, four states, say S1, S2, S3, S4. And in every state, you make one of the digit one. That is also possible. We will do it in the later, but right now we'll keep the code as simple as possible. So what we are going to do, we are going to write the combinational circuit. Okay. And what we are going to do is that we are based upon the case statement, we are going to switch between the different digits. Okay. So when the case based upon the count range value, last two digits. Okay. When they are 0, 0, we will display the digit data on the digit 1. When they are 0, 1, we are going to display it on the digit 2, digit 3, digit 4, and so on. Okay, so this is the in case. Okay, based upon this, so there will be four values: the 0, 0, then to the 0, 1, to the 1, 0, and to the 1, 1. Okay. Now, when it is 0, 0, we need to display the digit 1 on the, and the 0, 0 indicate that the we will be displaying the data on the digit 1. So we need to make the digit 1 enable, and we need to put the appropriate data on the digit on that 7-segment display. Okay. So now here, so when this is the counter is last two is 0, 0, that means we need to enable the digit 1. So that means we need to make sure that this guy is equal to 4-bit 1110. It's active low, so that means the first digit has been enabled. That is one thing we need to take care. Now, based upon now we need to uh, have the appropriate value for the corresponding cathode. So this will depends upon the what is the content of the corresponding digit 1. So again, we'll write another case statement based upon the value of the this guy. digit 1. Okay, suppose the digit 1 value is 0. That means you have to display the corresponding uh, 0 on the 7 segment display. So this value will be it's a 8-bit one. Out of 8 bits, 7 bit are for the 7 segment, and the last one LSB is for the decimal point. So what we need to do is that decimal point we need to make it as 1. That means it will be off. Always we don't want to use the decimal point. And the remaining one. So if you want to display the 0, that means what you need to do is that you need to make the one of the display off. Okay, so you can see that for that again you can look at online the last one, which is the G1 is off. So A B C D E F A B C D E F G A B C D. So that should be 4 A, B, C, D, E, F, G. That is how I'll display the 0. Okay. The same thing I need to write it for the this one. When digit is 1. So I'll just copy it. When it is 1, so I need to make sure that I make the B and C is equal to 1 because A will be off. A will be off. B and C is equal to 1 and rest 4 will be 1. Okay. Again, you can go to the online 7 segment. You will see that the A is the top 7 segment, and the B, C are on the right hand side. So we need to make them on. So 1, 0, 0 or 1, 1, 1, 1. The same thing I'll be doing it for the rest of the cases. Okay, so I have completed the code for the rest of the day. So for example, if you want to display 7, and then you can see that I have made A, B, C. So top one and the right hand segment on. So that will I'll display 7. Okay. And in the same thing, you can do it for the rest of the figure. For example, to display the 9, I have made only one off. That is on the left bottom one is I have made it off. Okay. So with this, you can see that when your counter is 0, 0, you will display, you are going to select the first digit and you are going to display the digit 1 on that 7 segment. Now, same thing I can copy it for the rest of the cases. So when I'm going to display on the second one, when the counter is 0, 1. Okay. So in this case, my digit input will be 2. The rest of the cases will remain the same. Only thing is I need to make sure that I select the second digit. Okay. Same process for the third digit. Okay. I'm going to just select the third digit. And here I need to make sure that I select the third digit. And for the last case, again the same one. I'm going to select the fourth digit. And I'm going to select the fourth digit using the anode. And the data will be displayed as per the digit 4. Okay. So this is how my code will work. Again, this is the one way of doing it. In the future one, since here we have only the 4 display. In the future one, we may convert this into the FSM to make it more structured. But this is fine. This looks fine. Okay. So this one. Okay. I think we are done with the code. We don't need to write the default one because it is always a 0, or we have covered all the conditions, so we don't need to write any default. Okay, and hopefully it should work out. Again, these are the output of the always block, so we need to define them as a register. Okay, so with this we have completed all the modules of the our code. So basically we have written completed the everything. Now what we need to do is that we need to connect this. What we need to do is that we need to connect this to the input clock. We need to connect this to the input switch. We need to connect this to the 7-segment display, and then we need to connect this to the 7-segment display. For that, we need to add the XDC file. So click on Add Sources, click on Add and Create Constraint, click on Next. Then here say Create File. So you can say Basys 3 file, okay, and click on Finish. Now, the constraint file is a very important if you want to test your code on the FPGA, because you need to connect the FPGA pins to the appropriate boards. For example, in the here you can see that we need to connect the FPGA output to the appropriate pins so that they can be connected to the 7-segment display. So for this constraint files is there, because you can see that these are the FPGA pins, and this pin output we need to connect it to the 7-segment. So these are the generic FPGA pins which can be connected to anywhere. So we need to connect it to the 7-segment. We need to enable that. So for that, we need a For that, we need a XDC file, which is the default XDC file, which is there in the GitHub, which is provided by the board manufacturer. So what we need to do is that we need to copy this generic file. Again, you can see this online. Okay. So we are going to copy this, and we are going to use this in our XDC file. Okay. By default, all the ports are disable other than some XDC. Okay, so what we need to do, you can see that we need to connect the clock signal to the input clock of 100 megahertz. So this is on the W5 pin. So we are connecting the W5 pin. So we need to connect it to the our main signal. So if you go to the main signal, this clock 100 megahertz signal, we should be connected to this clock 100 megahertz. Okay. So this is the first thing I need to do. So that what I'm doing, oscillator clock which is coming from the oscillator, I'm connecting it to my design, inside my design to my input clock 100 megahertz. Then I'm not going to use any switches, so I'm going to disable it. Okay. Later when we want to use it, we can use it. I'm not going to use any LED for now. So right now I'm going to disable it. I want to use the push button. So you can see that on the board. Let me show you. On the board, there are 5 push buttons are there. So I'm going to use the middle push buttons. So for that, I need to select the appropriate file using the button NC. So I'm going to connect it to the reset input. Okay. So this is my reset input. So I'm going to connect it. So my reset input, whenever that push button get pressed, this is to go, that input will be passed to this reset signal in my code. Now I'm not going to use a PMOD. We are going to use it in the next lab. So these are the PMOD XDC. By default, you can measure the temperature voltage of the pin. So I'll leave it as it is. Then there should be a 7-segment display. Okay. Yeah. So you can see that this is the 7-segment display. By default, they have, so the making use of this one helps you to otherwise you need to look at the pins and then do this manual one. By using the existing XDC file, you just need to modify this to connect it to your pin. So this is my segment 0. So I'm going to connect it to the cathode 0. Okay. So my segment 0 corresponds to that is segment A corresponds to the my MSB bit. Okay, this is how we have designed the code. So my MSB bit, so it is the 7th one. you need to be very careful about this. So this one corresponds to the 6th bit, because the way we have designed the code, our A segment is on the MSB and the last segment is on the LSB, followed by the DP point at the end. So you need to write the code appropriately. So this is my 5th bit. So this is my 4th bit. So this is my 1st bit. And then this is the DP, which is again my 0th bit of my cathode output. Okay, so this is my cathode connection, and then I'll have to do my anode connections. Again, anode. So this is my 0th bit, so there is no issue here. This is my first one. Okay, so with this, I have connected all my inputs and outputs. Okay, so let's hope that the connections and everything is done properly. Let's synthesize the design. In the synthesis, you will know whether you have made any major mistakes in the code. So make sure you look into all the messages and errors carefully. Okay, good. So synthesis is completed. Now we'll go to the implementation. So it will take some time. So I'll just pause the video till the implementation is done. Okay, so we got some error in the implementation. So we need to check. So there is some issue in the ports which we have connected, which is the anode port. So we need to see that what are the errors are there. Basically, there is some issue in the anode port. So let's look into there is some issue in the corresponding voltage level. So we need to verify those things again in the HPC file. Okay, unfortunately, I didn't record this part of the video. Basically, there was some formatting mistake in the XDC file, but there was no other error. So the XDC file remained the same. So you can see that in the XDC file, you have the pin 5 connected to this port. Then you have the 7-segment display. Okay, to connect it to the anode and the cathode, you have the reset. That's it. Nothing else is there in the XDC file. Okay, so after the implementation, I'll generate the bit stream. I'll pause the video and come back once the bit stream generation is completed. Okay, so the bit stream generation is completed. So in this case now, you can look at the reports and other things, but we will not go into the details. We'll go to the project folder. So you can see that this is the project folder. This is the lab. And in this project folder, you can see that once you go to the runs implementation, and here you will see that this is the bit stream. Now, since I am on the remote desktop, I'll copy this bitstream in my local desktop, and then I'll deploy this bitstream on my board. Okay, so I'm going to copy it, and I'm going to store it on my local desktop. Okay, so I have copied my bitstream in my local desktop. What I'm going to do is that I'm going to use the local view which can be any version. So I'm going to use the local 2019.1 version to download this bitstream on the FPGA board. Okay. So this is my local view order. So I'm going to switch on the board. So you can see that it will detect the board, and then here now I can program the device. In the program device, I need to give the appropriate paths for the bitstream, and then I click on program, and my board will get programmed. Okay, and then you can see the display on the board. Now, I'll show you how to see the corresponding. I'll show you the corresponding data display on the board. Okay, so this is the display on the board. You can see that the counter is running on the board. It's the second counter. It is incrementing at every 1 second. Okay, so now you can see that if I press the switch reset one, the counter will reset to 0. Okay, so this is the live demonstration. Now you can see that I can program the board again, so that you can see that the done pin on the FPGA. So now I have programmed, and you can see the corresponding display on the board. Okay, with this, we have completed the first lab of the advanced DSP, where we have discussed how to integrate the onboard 7-segment display for the displaying the seconds counter. In the next video, next lab, we will discuss how to display the seconds as well as minutes, and how to integrate the PMOD 7-segment display with the Basys 3 board. We will also discuss how to write the test bench in the lab. Thank you.